Hey everyone, today we are going to solve the LeetCode question sort integers by the number of 1 bit. Okay, so first of all, we can solve this question with this code. But this question is asking you about sort integers by the number of 1 bit. So I thought we should avoid built-in functions such as sort or bit count. So I'll show you a solution code without a built-in function. Okay, and I think there are two difficulties to solve this question. So the first one is how do you count 1 bit? And the second difficulty is how do you keep numbers in ascending order when multiple number has the same number of 1 bits? So let me explain one by one. Okay, so first difficulty is how do you count 1 bit? So actually there is a well-known algorithm to count bits. That algorithm uses bitwise AND operation between current number and the current number minus 1. So we will repeat the same bitwise AND operation until we get a 0, so that we can get a number of 1 bits. So let's see an example. Okay, so let's think about the current number is 7. In that case, we use a bitwise AND operation between current number, so 7 is 111, so 111, and current number minus 1, that means 6. 6 is 110, so 110. So we calculate these two numbers, and bitwise operation is for just in case when both numbers are 1, in that case that should be 1. So here 1 1, so 1, and here 1 0, so in that case 0. So we get a 1 1 0, so that means 6, right? So we repeat this calculation until 0. So next, so 1 1 1 0. So current number is 6. So that means current number minus 1 is 5, right? So 1 0 1. So 1 0 1. And then so 1 0 0, right? So now we get 4, right? 100. So 1 0 0. That means current number minus 1 is 3, 1 1. So 1 1. So in the case, so 0 0 0, right? So that means 0. So we finish the calculation. So how many times did we calculate? 3 times, right? So that's why. So a number of 1 bit is 3 for 7. So and let's check. So 7 is 111, right? So looks good. So that's how we can count the 1 bits. Okay, so second difficulty is how do you keep numbers in ascending order when multiple numbers have the same number of 1 bits? So let's think about the input array is like a 7 6 5. So in that case, 7 has 3 1. And 6 has 2 1, and 5 also has 2 1, right? So in that case, how do you keep the number in ascending order? So because look at the description, so we should return ascending order of this input array. So in that case, we should return like 5 6 7, oops, right? So how do you keep the numbers in ascending order? So my idea is to use heap. So more precisely, we use a min heap. And the data inside of heap is like this. So first number is the number of 1 bit, and second number is so coming from the input array. So 6 has 2 1, right? And 5 has 2 1. So we create this set of data and then put them into heap, so that heap reorder these data like 1 2 3, right? So in Python, usually heap is a min heap. So heap compare the first number 2 to 3. So take a minimum, so 2 or 2, one of these, right? And then after that, compare second number, and 5 is less than 6, right? So that's why 2 5 is a first data, and the 26 is the second data, and the 37 is the third data. So all we have to do is just take like a one by one, and then create a result list. And in that case, we only need a second number, right? Like a 5, 6, 7. So we can easily access second number in like a index, like an index 1. Yeah, so that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, create a list, let's say one list, and equal empty list, and start iteration for n in array. And so let's count 1 bits. So ones equals, so let's say count ones, and passing the n. So I create this function later. So after that, just append the ones to one list. Append, and so as I told you, so inside of data should be number of 1 bits and current number. So let's create a count ones. So def count ones and number, and always start 0 count, and while num, so until 0 we repeat this process. And yeah, this is a very easy. First of all, yeah, we calculate like two numbers, right? So num ampersand equal num minus 1. Yeah, actually that's it. And every time we execute the calculation, so count should be +1, and then in the end we should return just count. Very easy, right? And then after that, we create a heap. So heap q dot heap by and one list, and then create a result variable. So after that, let's iterate one list, and then all we have to do is just take data from heap and access index 1. So just append and heap q dot heap pop and one list and access index 1. Yeah, that's it. After that, just return result variable. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be, I think, order of n log n. So we take data from heap, so heap pop should be log n, and we execute n time, so that's why n log n. And the space complexity is, I think, on. So because we put ones and the current number set data to list, so that's why on. Yeah, so that's all I have for you today. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question.